Hello here. Today we're talking about volumes of solids specifically. We're going to do two base solids. Um, Solids with two congruent bases. In a 3D solid, the base is no longer a side, but it's the shape of a 2D area. All right, a three-dimensional solid. And we're going to talk about prisms and cylinders today. But the base is not a side length anymore. The base is now an area of a two-dimensional side, right, of the three-dimensional shape. So let's get into it here. Right here, I've got on the right, I've got a rectangular prism. It is a prism by definition because it has two congruent bases. A prism has two congruent bases. In this case, the congruent bases are rectangles. Now, in a rectangular prism, you can call all six of the sides, right? The left or the right side could be the base. That could be a base with area 12. See, the green has area 12. And now the height is the distance between the bases. The height could be 8. Right? So that'd be 12 times 8. Or we could say that for this rectangular prism, the front and the back, they would be 8 by 3 or 24 area bases in red. And then that would have a height of 4. 24 times 4 is 96. Or you could say that, probably most of us would say that the top and the bottom are the bases, just because it's sitting on that side. But again, it doesn't necessarily mean that the base is on the bottom, right? It is whatever the two congruent shapes are. But in our rectangular prisms, they're all congruent rectangles. So here we have a base area, all right, of 32 and a height of 3, and that's 96 total. All right, it's really, right, this red, it would be a rectangle. All right, I've got it kind of drawn, so it looks a little bit different, but it would be a rectangle of area 32, and then I'd have 3 units high of those stacked on top of each other. But the volume formula itself, capital V for volume, is equal to, now notice I have capital B. I don't have lowercase b for when in area it was the side length. Capital B is the area of the base shape, whatever the shape happens to be. So in this case, I'm going to have the base be 32. I have it 8 by 4 or 32 square inches or square units, and the height is 3 units. And so if I multiply those together, I get 96. Now, units to the third power, which we can call cubic units. Cubic, right? So the third power is cubic. All right, where's my little... Alright, so this thing here is a triangular prism. Oops, sorry. Triangular prism. Alright, now the base is a rectangle. At the bottom here, that's not the base of the prism. The base of the prism is the two congruent triangles. So it's a triangular prism, has two congruent triangles, and they're the bases. So the shape of this base is a triangle. Alright? So when I find capital B, capital B is going to be the area of this triangle. And this triangle has a height of 4 and a base of 6. So it would be 1/2 4 times 6. Or 12, right, square centimeters. The height is not 4 here. 4 is the height of the triangle, but the height here is the height of the prism, is the distance between the bases. So it's going to be 10 centimeters. So this formula here is going to be, the volume of it is going to be area of the base is 12, height is 10, volume is going to be 120, and then it's a volume, so it's units to the third power, in this case centimeters to the third, or cubic centimeters. So determine the shape of the base. Once you determine the shape of the base, alright, what is this? This I would call a hexagonal or hexagon prism. The two congruent bases are hexagons. So to find the area of the base, right, that's the area of the hexagon. Now, I don't have a formula for that necessarily, so I'm just going to kind of figure that out. Well, this rectangle, and I've got two triangles. The triangles each have, right, since this whole thing is 10 and this is 4 in the middle, the triangles each have a height of 3, and there are two of them, and they each have a base of 6. So the area of the rectangle part in the middle is 24, and then the two triangles would be 2 times 1/2 times 3 times 6. And 1, 2, and 1/2 are going to cancel out. So it's 24 plus 18, or that looks like, what is that, 30, 42? 42, and it's going to be square inches. The height here is not 10. Height is 15. Why? Well, because that's the distance between the bases. If the base is a hexagon, the distance between the two congruent hexagons is 15. So then, if move away, the volume is equal to, this is just 42 times 15, whatever that happens to be. And it's going to be inches to the third power because it's a volume. So we're going to use this to find this missing piece x here. The volume is 240 cubic centimeters. The area of the base, well, the base is a triangle again. It's not the bottom, it's the two congruent shapes, excuse me. So the base is a triangle, so I don't know what that is. The height in here is 12, right, because it's the distance between the two congruent triangles. So if I use ifsmu, I get 240 equals the area of the base times the height is 12. So divide that and you get 20 is equal to the area of the base. So that means that the triangle itself has an area of 20, which means that 8 times this has to be 40. So the height of the triangle is 5. And if this is a 5, 4, and a 5, and this is x, you see we've got our, now I said this is 4 because it's half of 8. You see we've got a right triangle here. So 4 squared plus 5 squared equals x squared. And so x is going to equal plus or minus, but we can disregard the minus one, root 41. And that would be the hypotenuse there of the triangle, right? Tough problem, a lot of things going on here. We had to use the volume formula, we had to solve that, and then use the area of the triangle to find that the height of the triangle was 5, and then use Pythagorean to find that x is root 41. Alright, and then we can use another one here. We've got the volume in terms of pi. A cylinder is just a circle prism. It's got two congruent circles. This we're looking at here, it looks like is a half cylinder. So we've got half, the shape of the base here is a half circle. So the area formula for that would be 1/2 pi r squared. The height here, again, is not low to bottom, but the height here would be 25 because it's the distance between the bases. So the volume is equal to the area of the base times the height. Volume is going to be 1/2 times. Now, if we look back at our circle here, this is 10, so the radius is only 5. So it's 1/2 of 25 pi, because that's pi r squared, times 25 is the height. And so 25 times 25 is 625. Thank you, Luke. So it's 625 over 2 pi. This would be cubic inches, would be the label. If you wanted to say 312.5 pi cubic inches, I would be okay with that as well. If you want to approximate the pi as 3.14, okay. Depending on what the directions say, you might want to do that too. Alright, and that's going to be the end of our thing. We're going to do a lot of practice with these, but again, the formula for every single one of these was the same, right? Area of the base, that changed depending on what shape the base was. But we multiplied that by the height, and the height was the distance between the bases. Namaste.